platform where the order is placed, the guy who ships it. So for each of these, we have to create accounting entries. So accounting entries are like payable debit notes, receivable credit notes, PDNs, RCNs, revenues, accruals, GMVs. So all this has to happen at scale, right? That is what is accounting. So what does this help in? It helps in providing financial clarity, decision making, compliance, and audit. We get audited. So we do at scale in Flipkart, right? What is happening with the accounting platform that we had, right? As and when an order is placed and an order is shipped, we listen to series of events, right? Hundreds of events from multiple sources. We collate it, do a transformation of those events, and then create accounting entries, right? And then if you see, the moment we say accounting entries, there is revenue involved, there is GMV involved, there are sellers involved, there are marketplace involved. So in real time, what happens is at the end of the month, right, once 1 month is done, we have to provide data to our financial stakeholders. So every time we provide data to financial stakeholders, there was a lot of to and fro's that was happening. This is not matching with that, this BU is not matching with this BU is business unit, right? So marketplace is not matching with, if I have to take in Flipkart's terms, Flipkart's marketplace is not matching with eCart, who delivers for us, right? So there's a lot of to and fro's, and for our CFOs, so all data that we provide directly goes to CFO's office. So for CFO to get a view, it was like 10th of a month, whereas the month starts at 1st, right? And we were so reactive, and our teams were working day and night. There was questions on audit, questions on compliance, questions on legal, all those things were coming to us. So this is what the problem statement we had. With that, we sat together. We thought this approach is completely reactive, wherein every day, if you see, if you have an agile team, right, every month 1 to 10 you waste in answering to queries, right? Where will you build any products? So that is where we changed our approach. We sat together. We built a platform called as Bolt, right, which still collates. We'll go in tech depth what all we did in that, but it just collates data from all the sources. Make sure that all sources, two sources, source and destinations, BUs, all are in match, right? Even before we give our reports to finance teams, right, it clearly shows what is the issue, where we have excess, where we have match, where there is short, where it is present in one system, where it is not present in other systems. So we are completely compliant there. Just to give you the scale that we are managing, one of the smallest accounting entry, our report for granular for compliance is around 1 TB. So if you can assess the scale for BBD, big billion days, how much scale that we would have, right? So this is the product we have built, just simple as that. We have kept it simple, synchronization between two systems. Our guys will talk about the tech part of it.
Yeah, thank you, Lakshmi, for the brief intro. So, as Lakshmi mentioned that, let's now dive into the technical aspect of it. So, as Lakshmi mentioned that while we process our data, it goes through multiple hops. So, in multiple hops, we have chances of transformations and enrichments going in each and every hops. So what we were doing earlier was that on the month end only, we are doing the reactive approach. That we were on the month end, we were reconciling the data sets in between two systems and then finding the gaps in between. So with Bolt as a product, what we did was that we rather did the proactive approach. Proactive approach as in sense, for example, we are doing in multiple hops. Within those hops only, we are going through we are finding the gaps. That what is the gap between, let's say, if finally the data set will go to a particular, form a particular report, then if it goes through multiple hops, then from one hop to second hop, if there is any gap, then we'll find it in between only. So yeah, so whatever enrichments and transformations were taking place in between, we find the gap in beforehand, and then we presented it. So these are the three components to it. First is the data preparation, second is matcher, and then the recon reports. So the first component, the data preparation one, it picks the data from multiple sources. We have connectors for MySQL, for Google Cloud Storage, and we also, so it picks the data and it makes sure, let's say in Flipkart we have the data could be of various different ecosystems. For example, the order data is completely different with respect to the payment data. But to get the final numbers, it has to be the order data needs to be compared to the payment data. So the data preparation layer, what it does is, it finally makes those two different data sources to be comparable. It transforms it in such a way that the data sets become comparable. So the operations which we have is, for example, for order data preparation, we, as we see, we are doing the aggregation operation. So data preparation layer is responsible for those operations to make the data comparable. So we are doing the aggregation operation for order data preparation, and for payment data preparation, let's say we are having this payment ID and this order to payment ID, and we are joining it so that it comes. This is a very lame example, the basic example of what there are a lot of operations and transformations which goes under hood. So finally, we get the data preparation layer gets the data in the comparable form for the next component to come in picture. So Rishi, can you explain?
Thanks, Vaibhav, for the explanation. So as we are talking about that, the recon system that we go, it goes to the multiple hops. So as the complexity of the data increases, the data sizes are increasing day by day. So in the Flipkart, we can say the terabytes of data we received in the different systems. So there is an invoice system, there is a payment system, there is a I2P system which make the sync between the payment and the invoices. Then there is a data altogether different for the fees, because Flipkart also collects different fees. So matching of these data, this complex data, we have to divide into the different components, as Vaibhav mentioned. Like we have a data preparation step where we have connected with the different sources, like we have a Hadoop, Hive layer, MongoDB, SQL, or we are building other layers also so that it can be connected with the other sources itself. So after data preparation, so the main constraint is that we have to compare the data in the minimum amount of the time. So that it's the generic system, we have to design the system in such a way so that it can handle like explosiveness of the data skewness, optimum repartition of the data, like reshuffling of the data, so that there can be a less reshuffling of the data, so that, because in the big data we know if we have a more serialization and deserialization and more exchange of the data, the timing will increase and we can get a lot of issue. Like in the previous session we are going to hear like out of memories issues like that. So we have to design like these components in a separate way, so the matcher handles all this. It compares the data, it's the generic system for wherever the data is from the different sources. It compares the data and classifies them into the different buckets that we have. Currently, on the overall level, we have 5 buckets, that is access, sort, matching, in dataset 1, in dataset 2. So going to the same example that Vaibhav explained, like the payment and the order. Suppose a customer has placed an order of 300 rupees and the same payment has been done. In the accounting entries, it is only 200 rupees. So there is a more amount to the invoice rather than the payment. So there is a short of payment for that. There is a short of that payment. So we classify them into the short bucket. Now access, suppose if payment that has been done, that is more than that the order has been placed. So there is some issue in the system, maybe in the Kafka, maybe in some events, so that it got misplaced. So that will come into the access bucket. Now matching is the happy case scenario where whatever the customer has placed the order, the same payment has been done. So it is like LHS is equal to the RHS. Now it may be possible कि suppose the order has been placed but the payment has not been done. So that will come to it is present in that ordered table but not present in the payment table, and vice versa. So the same example that if you can see here, we have that different data sources that are residing in the different infrastructure, not in the same infrastructure also. So we have a different net amount, we are dividing into the different categories, handling it, dividing the different bucket itself. So this is the overall bucket, but suppose there are some issues Like we know there is a system failure, there can be an ingestion issue in one of the system, and the gap can between it can be solved in 1 to 2 days. So this 4 bucket can be further divided into the whatever the data can be reinvestigated, or what is the timing issue that can be resolved in some amount of time that we don't have to look into. So the final layer that we have built is the recon report, where the consumer can consume the data. So we have the matcher job, which generates the different reports for the reconciliation, and that is fed into the recon report that consumer will be able to consume it. So if you see the generic view, like some of the view that we have, like the trend of the difference of the recons for, if I go to the same use case of the order and the payment, the trend of the differences of the orders and payment at each of the day of the month, so that the consumer or the customer that we have a confidence that the system is going in a smooth way. And this has not been done in only like final level. It has been, it is doing it at each level of the system. Suppose we have a different system, like the data has been coming from the events to the Kafka, then Kafka to the on-premises or the cloud. Then we have a Apache HDFS, Hadoop distributed system. From there, it is going in the batches from, and we have a different fact layer, then gold layer, silver layer, bronze layer. So there is a different system itself. So this recon, this recon system that we have is able to analyze at the different hop level. And from this overall report that we have, we will be able to do the RCA and doing the exception classification. So basically, whenever the user got the report, so it may happen, now you have to, based on these reports, the user have a flexibility to design their own view also. Suppose they want to do the RCA key, if my data is stuck in some queue or in some other place, or it has been posted to Oracle or not, some ingestion issue and re-ingestion issue, so that they will be able to do with RCA with the help of this recon reports. So this is all about the recon reports. So now I will hand over the mic to the architect who have designed all this.
Yeah, thank you, Rishi. Thank you, Lakshmi, for the initial summary of what this product is. And thank you, Vaibhav, as well. I hope you have understood the key theme of what we are trying to solve here. We are trying to make our accounting system from reactive to a proactive system. So being reactive, it used to take us a lot of time to deliver the financial reports that we wanted to deliver. While being reactive, we are able to do it in much faster time. And the second theme is, if we have to do it in a proactive way, there is a lot of data crunching that we have to do. So we need to harness the right technologies so that we can do this computation at a very high scale. So we look at this technologies as a universe of various technologies that can be there. At the core of it, we have data. So without data, I guess nothing will work. Without data, there is no accounting, there is no, even AI will not work without accounting, without data. So at the core of our data is our different databases that we have in our ecosystem. So currently we have integration with MySQL, with Hadoop, and some part of the Google Cloud Storage as well. These covers almost like 90% of our database scenario, which we can do our reconciliation on. Once the data is being fed into the execution layer, that is the computer of our reconciliation via the connector layer. So each of these databases have their own connector layer. For MySQL and Hive, we use Spark SQL. At different places, we use BigQuery as well. Sometimes we use Google Cloud APIs to read the data from GCP. Once this data is being present in our, has been read from the connector into the execution layer, there can be different execution layer that can be used. So in execution, there are two parts. How do you want to execute is being done as an expression, as a SQL expression, and to execute that SQL expression. So currently, we have built a custom expression language which can perform all the operations that we talked about, that join, aggregation, matching, all of these are custom operations that the system can do. And then the execution part where these operations will be done. So we have built the system in such a generic way that this can be executed at different execution layers. It can be executed in a on-prem Spark setup. It can be done executed on an on-prem Flink setup as well. While it can be done in cloud as well, where you can use Dataproc clusters or you can use Azure compute clusters to do these computation. As we said, once the computer has done the job and the data has been computed and we have the reconciliation output that is being there, it has to be fed to the final consumers. Those are the financial users who wants to consume this data. So for that, we are using Facebook Metabase. So it provides a fancy UI. You have seen the example of that, and it is very easy to configure it as well. But this is just the beginning. In future, we are looking to integrate with all of these technologies, which will cover a lot of our database entities. Also, it will cover all of our, most of our consumer base as well. So not only finance, legals, and others who have different technologies in their stack, they will be able to consume this data. What is the impact of this? So just to tell you, if you can guess, what is this 2 billion number? What do you think this is? Savings on orders? No. Number of transactions. Okay. At what frequency you think these are number of transactions? 15 minutes. Okay. No, not 15 minutes. So 2 billions is the number of rows that we compare daily. These are the reconciliation that we do daily. And again, this product is not something which is built for accounting. This can be used for any general purpose reconciliation. So in one of the talks, somebody was talking about the complexity of doing migrations. So you can, in migration, you have to compare the data from old to new. So you can use this product to do that migration, do that comparison for the old system and the new system as well. 15 minutes is the time we take to compare this much of data. And just for another question, how much storage space you think this 2 million would have been taking? Yeah, it depends on number of columns. The kind of complexity we have in Flipkart, this data is in petabytes. So with the kind of technologies that we use, we are able to process this much of amount of data in 15 minutes time duration. What does it finally give us the impact? So as Lakshmi mentioned, the smaller the cycle we are able to deliver the report, more time the stakeholders, the financial, the CFO, they have for doing demand planning, they have time for doing a lot of other financial decisions. We are able to deliver it in next day itself. That is the power of this product. With this, I would want you to meet the team. We don't have Abhijit here today. He had a family emergency because of which he could not join today. But we have Rishi and Vaibhav who has built the system from scratch. They have been experimenting with different technologies and they have implemented these generic interfaces on these different technologies, and it can be expanded and extended to integrate with all new technologies. We have Lakshmi here. We don't have Ganesh and Venkat, who were the mentors during this journey. Any questions? Yep. So currently it is an, you can say, a hybrid model. Some part of it is on prem, some part of it is on GCP as well. So if you see, as I mentioned, the execution engine is comprising of Spark streaming as well as Dataproc. So the same Spark job that we run today